Assalamualaikum warahmatullahi wabarakatuh. To my panel, Dr. Bibi, Intan, Suraya and Dr. Azimin. I am Muhammad Adik bin Mazlan and I am under the supervision of Dr. Nur Hafiz bin Muhammad Nur. So, here I am today to present my final year project proposal entitled Strength Analysis of Ultra High Strength by Spot Weld. So, before we begin, I would like to explain a little bit about the title here, Strength Analysis of Ultra High Strength by Spot Weld. In this project, we're going to analyze the strength of a welding type, which is spot weld. The welding is welded at a steel ultra high strength metal. We're going to analyze it by using Finite Element Method, FEM. Okay. Let us begin with introduction or background of the study. Before we go deeper on our scope, let us start with a wider scope here. Welding. Welding is one of a joining method we use in joining metal. Welding join metal by creating a homogeneous joint between base materials. According to Manurung et al., welding is one of the most efficient, dependable and economical method in joining metal during fabrication. Today, welding is a main method in joining metal to make and fabricate products. Welding strength plays an important role in a welded metal structure. Strong welding joint ensure the structural integrity of metal structure, which is very important in many industrial sectors. For example, in mechanical equipment manufacturer sector, a strong welded joint is a key to the functionality and durability of a product. Charles Manurung et al. Said, a strong welded joint shows the successfulness of a welding process. Okay, now we go deeper in our scope based on the title Spot Weld or Resistance Spot Welding. Resistance spot welding is a type of welding method. In general, resistance spot weld is widely used in joining sheet metals. You can see at the picture there is resistance spot welding in process. Usually it is an automated process. There are many other welding methods in joining sheet metal, but for the big and high output manufacturers, they prefer resistance spot weld method due to the advantage of time and cost efficient. Resistance spot welding is fast, cheap and can easily weld different metal together, which are sometimes impossible to join by other welding method. Resistance spot weld also is a very important process in automotive industry for fabricating car bodies. As you can see over there at the picture, the sparkling from spot weld in automotive assembly line. It is very popular in automotive industry as it is robust, fast, which is very important in manufacturing sector, and low cost to operate. All the characteristic is very much needed because 3,000 to 5,000 spots welding are needed in an automobile. Okay. Ultra high strength steel, UHSS. Application is wide in automotive industry. According to Abed et al., the characteristic of UHSS, which are very high strength to weight ratio, make it very popular in automotive industry. Generally, UHSS are joined by spot welding, with automotive industry nowadays targeting for their vehicle to be in weight reduction. The UHSS usage so up. In analyzing weld strength, apart from mechanical or experimental ways, usage of finite element method simulation are very popular right now. It can save time and money compared to experimental method. Sometimes experimental method cannot analyze some discrete part of something, and FEM method is a way to go. Next, we go to literature review. So basically, resistance spot weld is a welding technique that joins two or more metal sheets through fusion on the contact area of electrode tips. This procedure basically make use of two copper electrodes to compress the sheets together and supplies huge amount of current through the contact area of electrodes. Once the melting point of the steel is reached, the steel will begin to fuse and nuggets start to form. The current then switch off and the nugget is cooled down and solidified under pressure. You can refer at the top picture over there, the spot welding process, and the bottom picture is the resistance spot welding in progress. Ultra high strength steel, UHSS. UHSS are steels that its tensile strength exceeding 780 megapascal. We can see at the aeroplane light graph over there, DP, dual phase, CP, complex phase, MS, and all the orange one there, which exceeds 780 megapascal tensile strength, is UHSS. UHSS is a carefully crafted metals. Various strengthening mechanisms are employed to achieve a range of strength, ductility, toughness, and fatigue properties. UHSS JSC 980YL, which is our UHSS type that we use in this project. It is a dual phase cold roll UHSS. Dual phase steel consists of hard magnetic or magnetic second phase in the form of islands dispersed in ferritic matrix. JSC 980YL is actually just a code name used in Japan for its designation and standard, whereas its generic name is actually the DP 980Y600 CE. We can see at the pie chart there, UHSS dual phase consists of 34% of the body in white structure, mainly in cabin structure. Heat affected zone, HAZ. The heat affected zone is a non-melted area of metal that has undergone changes in material properties as a result of being exposed to high temperature during welding. Because as the metal exposed to heat, it is like going into heat treatment of metal. In the term of material science, the microstructure of the base metal change due to the heat exposure during welding. At the picture there, you can see the blue color at the welded metal is actually the heat affected zone. The software that we use in this project, LS-DYNA. LS-DYNA is a finite element program which is quite famous and is actually developed in 1976. It is a general purpose finite element program capable of simulating complex real world problems. LS-DYNA is the most used simulation program capable of simulating the response of materials to short periods of severe loading. More or less like a top-notch simulating software. As we go into the problem statement and objective, resistance spot weld is used in fabricating a car body in white, which is a mainframe of a car. As you can see over there, the body in white acts as a load bearer of the car. As a car is always under loads, plus with the road condition, these loads can cause a failure of the spot welded joint at the body in white. So it is very important to study the failure behaviour of spot welded joint in body in white component. In analyzing the strength of the spot weld, there are some challenges. In heat affected zone, the distribution of stress and strain are different due to its different mechanical properties throughout the area. So the HAZ needed to be modeled in detail and cannot be generalized as a same material overall. And other challenge, the small size of the spot weld structure also make the mechanical testing difficult. So local analyzing is needed in analyze the data from the mechanical testing. Okay, the objective of the project are to study the strength of UHSS in the spot weld process, to determine the mechanical properties of spot weld specimen, to the design and simulate the strength analysis of miniature spot weld specimen, to investigate and determine the method in analyzing the heat affected zone of spot weld. Next, we go to the scope and limitation of our project. In this project, resistance spot welding method is to be studied in terms of its strength. It is involving both mechanical testing and finite element simulation. RT specimen test will be simulated in finite element simulation with the data from tensile test. LS-DYNA will be the software used in the simulation, and the limitation of the project is the simulation data distribution accuracy will be not exact as the experimental result. Next, we go to the methodology of the project. This is the flowchart of the project. We start from the experimental work, consists of tensile test and LT specimen test. Then the simulation work start with apply crack and wide and boundary condition to the model. Then we check it first. If the model is okay, then we go to second failure analysis towards the end. Okay, to enhance a little bit about the project flow, the material we use is 1.6 mm JIC 980 YL spot welded steel plates. The experimental work data from both tensile and LT specimen test will be used in simulation work to simulate LT specimen test. In other words, to verify the LT specimen test data from mechanical testing. Okay, in uniaxial tensile test, we want to determine the mechanical properties of weld and base metal, in which the output is stress strain of the base metal and stress strain of the spot weld structure. You can see the picture there, the tensile bar with a spot weld there at the notch and the machine used there. In LT specimen test, we want data that describe the fracture behaviour of the spot weld, which is force vs displacement data. You can see the LT specimen is being pulled by the tensile machine there. It is more like peeling the welded plate. In simulation, we going to simulate and analyze computationally the LT specimen test. The input which from the experimental work are material properties, boundary, conditions, time, pieces velocity of jaw, stress and strain of the materials. The output is displacement, force and strain. Our expected result. So at the end of the project, a good agreement between FEM analysis and experimental work is expected. The result of simulation should be more or less same from the RT specimen test with varying accuracy. There will be two failures same as the mechanical testing, and the accuracy of the result will be depending on the accuracy of the heat affected zone modeling. Okay, that's the end of the presentation. Thank you to Dr. Bibi, Intan, Suraya and Dr. Azimin for spending time watching my proposal video. And thank you to my supervisor, Dr. Nur Hafiz, for guiding me. And that's all from me. Wishing all of you good health and happiness. Assalamualaikum warahmatullahi wabarakatuh.